All right, 6-4, logarithmic functions. Last video, we talked about what is a logarithm. So today we're going to look at what does it look like to graph a logarithm. Okay, so this first example is y equals 1/2 x, or log base 1/2 x, sorry. So functions, the log base a, I'm going to put 1 divided by 2. Ooh. Actually, I'm going to make it easier. I'm just going to put 0.5 because 1/2 is the same thing as 0.5 x. So here's what it looks like. So if I draw myself a little picture here, notice, let's change the color here, that it is getting close to 0 but never actually touching that y-axis. So sketch yourself a little picture there. So when I talk about all the things here, let's see, domain, range, asymptotes, then what I'm looking at is the domain starts at 0, but it doesn't actually touch 0. And then it goes to the right forever. So remember, domain is left to right. Well, the farthest left that it goes is 0, but then it goes right forever. So that is 0 to infinity. Now, sometimes it's hard to tell, but this starts way up high forever. And what's harder to tell is that it's actually going down forever. It's going down forever slowly, but it is going down forever. So the range is -infinity to infinity. And the asymptote is a vertical line, so vertical is x equals, at 0. And then last, end behavior. End behavior is written out more confusing than it really is. We want to know, as x goes left and as x goes right, what in the world happens to y? Okay, well, x doesn't go left forever. X stops at 0. So you do your domain there. And as it goes to 0, y is going up, up, up forever and ever and ever. And as x is getting bigger, it's going down, so it goes to -infinity forever. All right. Yet again, we see transformations. So they're the same as before. I'm going to graph this in a line, and I'm going to graph this in a line, and we're going to see how they compare. If there are no parentheses around the whole group, so notice that does not exist, right? Then I need to assume that this is its own entity, and then +4 is at the end. All right, so ln(x) is the parent graph, looks like this. ln(x) and then +4 looks like this. Notice from red to blue it went up 4. So up 4. If the number is out front, then that is a vertical stretch. If I had something like this, that would mean left 4 if it's on the inside. Okay. So if I want to find the inverse, we did inverses in 5-6, which was our very first unit of the semester. And so it's been a while. But remember, to find the inverse, we switch x and y and then solve for y. So anywhere that there's an f of x, we actually put y. Okay. So step 1, switch x and y. So notice where there was an x, I put y. Where there was a y, I put x. Here's what we have. Next, I want to use what we learned last class about converting forms. So if I want to switch it to log form, it's log base 3, because that's the base of the exponent, of x equals the exponent. We're getting closer to getting y by itself. My last step would be to subtract 2. So this would be the inverse of that. What if I wanted to go the other way? This is y, so step 1 is to switch them. Okay. I want to move that -2 over first because I want that log by itself. Now I can convert forms. So I start with the base of the answer equals y. And just like that.